Hello everyone, welcome to Success Spectrum Academy. In today's session, we will explain or we will explore, we can say. I'm going to explain it, okay, an exciting topic from ICSE Class 10 Physics, that is Spectra. Have you ever wondered how we see rainbow in the sky and why the light split into different colors? So if white light is passing through the prism, so you can see it, that is means divided into 7 different colors. So have you ever wondered why these things are happen? So in this chapter we will uncover the fascinating world of light and color, discussing the description, spectra and their real life application. So stay tuned and let's dive into the world of optics, okay, that is we can say spectrum. So let's begin this chapter. So here you can see the first topic we have deviation produced by a triangular prism. Okay. So when a ray of light passes from one medium to another medium, it gets deviated from its path. Okay. This chapter is means we can say belongs to optics. Okay, from class 10th ICSE. Okay, physics, that is I'm going to take today. Okay. So it's get deviated from its path because of means we can say the difference in speed of light in two media. So means that is rarer medium and denser medium, we can say there are two medium we have. Okay, so the deviation produced by a triangular prism is shown below. Here you can see, okay, this is the incident ray we have. Okay, so the light source, this is monochromatic light we are taking, right? This light source we have, and this light source is passing through a slit, okay, this P we can say. So it producing an incident ray, okay, that will strike at point Q here on the prism of side AB. Okay, so that will be deviated. Here I can see this will be the angle of deviation delta 1 again, and here it will be, this will be the emergent ray. Okay, so now for emergent ray RS, now here case for emergent ray RS, the total deviation delta with respect to incident ray PQ is given by delta equal to delta 1 plus delta 2. So this delta means total deviation equal to what? Delta 1 plus this delta 2 we have. So thus the total angle deviation depends on the following three factors. So what are those three factors? Angle of incident at the first surface, angle of the prism. So here we can see this is the angle of the prism here. Okay, this will be the angle of the prism, we can say A. Okay, so now angle of the prism A and refractive index of the material of the prism mu. So these three factors we have. Thus the total angle deviation depends on the following three factor, we can say: angle of prism, angle of incident at the first surface, and refractive index of the material of the prism. So because the refractive index depends on the color or wavelength lambda of light used, so the angle of deviation depends on the color of incident light. Okay. So deviation produced by a triangular prism. So here in the figure you can see the deviation produced by a triangular prism when a light ray PQ of single color enters a triangular prism, that is ABC given here. Okay, it's get deviated say by angle delta 1. So here in this prism you can see it get deviated by the angle delta 1. So this angle we can say delta 1 towards the base BC. So it will be deviated towards the base BC. Okay. Now from this another surface we have, that is AC now. Okay. So the first surface AB of the prism and travels straight as QR inside the prism. So it will travel inside, means the prism as a straight line, we can say. Here it is QR inside the prism. So the angle of deviation delta 1 depends on the angle of incidence. So this angle of deviation delta 1 depends upon angle of incident I. And the refractive index of glass with respect to air. So on striking the second surface AC, the ray means here QR, okay, it is striking the surface AC now. Okay, so the ray QR gets further deviated, right? say by an angle delta 2. So it is deviated by an angle delta 2. So it will pass like this in a straight line, but it is deviated like this, means towards the AC. Okay. So now it will depends on the angle of incident at the second surface, which depends on the angle of the prism A, and the refractive index air with respect to glass. So refractive index of air with respect to glass in first case, refractive index of glass with respect to air in the second case, we can say that is refractive index of air with respect to glass here. Okay, first case it was glass with respect to air, now second case air with respect to glass. So for the emergent ray RS, the total deviation delta with respect to incident ray PQ, that is angle between the emergent ray RS and the direction PL. So here you can see this will be the delta we have. So delta equal to what? Delta 1 plus delta 2. So delta 1 will be delta 1 plus delta 2. So this will be PL, we can say here. Okay. So the total angle of deviation delta thus depends upon the following three factors that we discussed already: the angle of incident I at the first surface, the angle of the prism A, and the refractive index of the material of the prism. But refractive index depends on the color, or we can say wavelength, that is lambda of the light used. So angle of deviation depends also on the color or wavelength, that is lambda of the incident light. Now these are three factors. Okay, angle of incident at the face, angle of the prism, refractive index of the material. Okay, because of refractive index depends on the color or wavelength lambda of light used, so the angle of deviation depends on the color of incident light as well. Then dependence of deviation on color or wavelength of light. So light of different color has different speed in a medium. So the speed of light in transparent medium decreases with decrease in the wavelength of light. The light of different color has different speed. Okay, so suppose we have the red light, red color. Okay, so red color we are taking, the blue color, green color. So they having different speed in a medium. So the speed of light in a transparent medium decreases with decrease in the wavelength of light. So if wavelength of light is decreases, the speed of light is also decreases in transparent medium. So therefore the refractive index of glass increases with decrease in the wavelength of light. So now here I can see this, the refractive index of glass increases with what? Decrease in the wavelength of light. So the deviation increase with decrease in the wavelength. Thus the visible spectrum red color lambda equal to how much? 7000 angstrom is deviated the least, and violet color, that is lambda equal to 4000. So here you can see the difference between the wavelength. So for red color it is 7000 angstrom, and for violet color it is 4000 angstrom. Thus the visible spectrum red color deviated the least. Okay, so it having the maximum wavelength, and violet color will deviate the most, it having the least. Here I can see this, or lesser than red color, right? It's no, the wavelength is lesser than red color. So it is 4000 and it is 7000. We can compare. So now dispersion of white light through a prism and formation of spectrum. So now I can see this. Newton allowed the white light, right? Newton allowed the white light, okay, from the sun to enter the darkened room, okay, through a small aperture. So he was experimenting in a room. Okay, so he took a small aperture, and from that the white light entering to his room, okay, in a window, and placed a glass prism. So now he placed a glass prism, we can say. Okay, now path of the light ray, and found light emerging with the colors of rainbow. So now he found what? That light is emerging in the color of rainbow, means that white light is divided into 7 color. Okay, the color band is termed as spectrum. So this color band is known as spectrum. That 7 colors means white light is deviated into 7 colors from a glass prism. So while in the rainy season you can see in the sky that is cloud, or we can say due to the atmosphere, okay, the rainbow is forming in 7 different color, so that is also means we can say spectrum. So starting from the side of the base of the prism, the color in the spectrum of screen are in the following order: violet, indigo, blue, green, yellow, orange and red. So the order of color can easily be remembered as Vibgyor. So in short form you can remember this as Vibgyor. So we discussed here dispersion of white light through a prism and formation of spectrum. So this was given by Newton. So Newton was set an experiment in his room that he allowed the white light pass through his window through a small aperture, or we can say small slit in the window, and he placed a glass prism in the path of light ray and found light emerging with colors of rainbow. This color band is termed as spectrum. Okay. So starting from the side of the base of the prism, the colors in the spectrum on the screen are following order: violet, indigo, blue, green, yellow, orange and red. So in short we can remember this as, or abbreviated as, Vibgyor. So V stand for violet, I stand for indigo, B stand for blue, E stand for green, Y stand for yellow, O stand for orange and R stand for the red color. So here I can see this is the small aperture, okay, in a window, and the white light is passing through this prism, and that is divided into 7 different color, that is V, I, B, G, Y, O, R, violet, okay, indigo, blue, green, orange, or means here it is yellow, orange and red. Okay, these are the 7 color. He placed a white screen, okay, to collect these colors. Okay, so here, okay, that rays will be deviated into 7 different color. That white light consists of a mixture of 7 different, can say. So what do you mean by dispersion and spectrum? The phenomena of splitting of white light by a prism into constituent color is known as dispersion. So here white light means here by a prism into its constituent color. So white light is divided into or deviated into 7 different color when it is passing through a prism. Then this is known as dispersion. And the band of color, so the band of color is known as, okay, that is obtained on the screen, okay, are termed as or known as spectrum. That is, the band of colors obtained on the screen on passing white light through a prism is called a spectrum. Okay, so what are the cause of dispersion we have? Here it is the cause of dispersion, okay, is the change in speed of light with wavelength or frequency. So when the wavelength of the light is changing, the dispersion, okay, the dispersion is the change in speed of light. So it is, dispersion is what? The change in speed of light with wavelength. Okay, speed of light with wavelength or frequency. Red color is deviated the least, so it having the greatest wavelength, while violet color is deviated most, it having the least wavelength. On the second surface of the prism, only refraction occurs from glass to air. This is the medium 1, glass is medium 1 and air is medium 2. So when the ray is passing from glass to air, deviations is occurs, okay, that is refraction is occurs, we can say. And different colors are deviated from different angle, that is violet is deviated most. So here you can see this is the prism, then white light is passing, so violet is deviated the most, but red color is deviated least, we can say. As a result, the colors get further separated on refraction at second surface. So the light coming out of the prism thus has different color that spread out to form a spectrum. So that color are collected on the screen, that color band are called as or known as spectrum. Then here you can see this recombination of colors. So when white light is passed through one prism, and that is divided into 7 colors, and that 7 color again pass through another prism, so it will be look like a glass slab now. So this white light will be, means here again producing that same white light. So the colors of spectrum. Here you can see this, the color of spectrum of white light combined to reproduce white light again. So here I can see this is the source. Okay, so from here the white light is producing, and this is the first prism we have, and this is the another. Okay, that is inverted prism we are taking. So when the rays are passing through this is red color and violet color. So red deviated and violet deviated most. So again the violet color and red color combine to give white color back here on the screen. So the two prisms combined together effectively act like a parallel. We can see this, right? Yes, no. So it is a parallel sided glass slab. Okay. So this experiment shows that what P1 simply dress the white light into constant color, the white light again. So none of two prism produces color by itself. Next, here you can see electromagnetic spectrum. So the portion of the spectrum between red and violet color is visible spectrum, or simply we can say visible region. Okay, and it is only a small entire electromagnetic. It is a small part, we can say, from 7,000 nanometer to 4,000 nanometer, or 700 nanometer to 400 nanometer, or 7,000 angstrom to 4,000 angstrom, we can say. The portion of spectrum just beyond the red is called infrared spectrum. So beyond the red is known as infrared spectrum, while the portion of the spectrum just before the violet is called ultraviolet region. So here you can see this is UV spectrum, and here it is IR spectrum. So this side we have infrared, and this we have ultraviolet. So the waves of wavelength longer than the red part of the visible spectrum is increasing order of wavelength are infrared radiation, microwave, and radio waves. Waves of wavelength shorter than the violet part of the visible spectrum is decreasing order are ultraviolet rays like X-rays and gamma rays. So the speed of these waves is equal to the speed of light. So what is speed of light? It is C equal to 3 into 10 to the power 8 meter per second. So speed of waves is equal to speed of light. So the speed of frequency and wavelength of electromagnetic waves are related as C equal to nu lambda. Nu will be the frequency and C is speed of light, we can say. So here it is. This will be V lambda, we can say. So properties of electromagnetic waves. So these waves do not require any material medium for their propagation. So they travel with the same speed in vacuum or air, which is same as the speed of light. So they exhibit the properties of reflection and refraction both. Okay. So here reflection and refraction, these topics are included there, means in detail in class 11th, while you are moving in class 11th and 12th. Okay, that time in the chapter named as in class 12th, basically trace reflection and refraction comes under the chapter optics. So these waves are not affected by electric and magnetic fields. These are transverse waves. These are the characteristics of electromagnetic waves, we can say. Next we have properties and uses of radiation of electromagnetic spectrum. So here properties and uses of radiations of electromagnetic spectrum. First we have gamma rays. So gamma rays, these are, we can say here, most energetic electromagnetic radiation. So these are most energetic electromagnetic radiations of wavelength less than 0.1 angstrom or 0.01 nanometer. They are obtained in emission from radioactive substance due to energy change in the nucleus of their atoms. So here these are obtaining from the radioactive substance like uranium, thorium, etc. Like X-rays, okay, they cause fluorescence when they strike the fluorescent material such as zinc sulfide. They can easily penetrate through thick metallic sheets they can easily penetrate through the human body and cause immense damage also, right? Gamma rays can means penetrate through the human bodies, okay, in medical science to kill cancer cells. So it can penetrate the human, the bones also, it can penetrate through the human body. In industry to check welding also we are using gamma rays. Then next property we have X-ray here. So X-ray are produced when high energetic. So here I can say this, X-ray are produced when highly energetic cathode rays are stopped by heavy metal target of high melting point. We have wavelength, okay, so we are using for scan our bones. So X-ray cannot penetrate our bones. So X-rays are used when highly energetic cathode rays are stopped by heavy metal of high melting point. They have wavelength in the range of 1 angstrom to 2 angstrom, or can 0.01 to the power, 10 nanometer. They are chemically more active radiations. Here it is. They are chemically more active radiations than ultraviolet radiation. They strongly affect photographic plate. They cause fluorescence in materials such as zinc sulfide. They penetrate the human body, but they are stopped by the bones. So to get the structure of bone or defected bones, we are using X-ray to get the actual picture of the bones. So because they are stopped by the bones, they are used to detect the fractures in bone, teeth, etc., and for diagnostic purpose such as here CAT scan in medical science. They are also used for studying atomic arrangement in crystal as well as in complex molecules. They are used by detective agencies to detect what? Your consolidated precious metals also. Okay, so that metals having means heavy melting point, okay, we cannot penetrate them, so we are using X-ray here. Okay, then ultraviolet radiations. So properties of ultraviolet radiations: can pass through quartz, but they are absorbed by glass. The radiation travels in straight line with speed 3 into 10 to the power 8 meter per second in air or vacuum. They are usually scattered by dust particle present in the atmosphere. So these are ultraviolet radiation produced by sun. Okay, so they obey the law of reflection and refraction both. They strongly affect photographic plate as they are chemically more active. They produce fluorescence on striking a zinc sulfide screen. They cause health hazards such as skin cancer if the body is exposed to them, or if the body is in contact with ultraviolet radiation for more time or for long. Uses for sterilizing purpose, for detecting the purity of gems, eggs and geese, etc., and in producing vitamin D, in producing food of plants and animal. Okay, then we have visible region or visible light here. Okay, so here you can see properties. The electromagnetic radiation of wavelength from 4000 angstrom to 8000 angstrom are called visible radiation. The sun and electric bulb, a flame and hot bodies are main source of visible light. The primary colors of visible light are violet, indigo, blue, green, orange and red. Your uses visible light is used in photography and photosynthesis and to see the object around us. So while we are seeing around us, we are using the visible light. Okay, that will be uses for visible. That's all for today's lesson on spectrum. I hope you found this session that is insightful and easy to understand. If you enjoyed learning with me, okay, don't forget to like this video, share it with your friend, and subscribe to Success Spectrum Academy for more such informative lesson. Also hit the bell icon so you never miss an update. See you in the next session. Keep learning and keep signing. Thank you for watching.